Munchkins. Today we're doing Lesson 8, Session 5. There's only 2 pages that need to be completed in this. These 2 pages I think are going to be really easy for you. This is all review. Number 1, apply it, solve the problems. Delilah makes this model to solve a problem. What problem does she solve? Write an equation. So I can tell, because the arrows are going backwards, that this is going to be a subtraction problem. Plus down here, there's already a subtraction symbol. So 93, 90, and then we have an arrow to 70, and we have an arrow from 70 to 66. So with subtraction, we always start with the biggest number first. So my biggest number is going to be 93, and we're going to see how many hops, how many jumps back we took. So 90 to 93 is 3 hops, right? 70 to 90, 70 to 80 is 10, because we're counting by tens. Any numbers that ends in zeros, we count by 10. 70 to 80 is 10, 80 to 90 is 20. So that's 20 hops. I always circle up here. And then 66 to 70, 67, 68, 69, 70. 67, 68, 69, 70. 4 hops. So we take all our circled numbers and we add them together, right? 20 plus 3 plus 4. How many is that? 0 plus 3 equals 3. 3 plus 4, this is our 7. Bring down the 2. So 27. So 93 is our biggest number. Minus 27 is going to equal what? We knew before we started what our beginning number and what our end number was going to be. 93 minus 27 equals 66. So that wasn't hard, right? We know how to do that using an open number line. Now we're going to go on to number 2. Hi, okay, a farmer has 76 horses. There's 27 horses inside the barn. The rest are outside. How many horses are outside? So first I'd say to myself, is this going to be an addition or a subtraction problem? Then I would realize that it's going to be a subtraction problem. And what do I know? I know the whole is 76 and the part is 27. So if I'm going to subtract, I'm going to use an open number line. Here's 76 horses, because that's the total, and I'm going to need 27 is how many are inside. So I always bring this to the nearest 10, 76 to here, and then I've got to go down to 20 or to 30, because that would be the nearest 10 here. So 70, 60, counting backwards, 50, 40. So these are going to do all my hops. I'll draw my arrows and then I'll go back. 70 to 76 is 6 hops. 70 to 60 is 10, because these are ending in zeros. 60 to 50 is 10. 50 to 40 is 10. 40 to 30 is 10. And then 27 to 30. 28, 29, 30. That's 3 hops. So, 3 hops. 10, 20, 30, 40. So all this equals 40. So I'm going to take 40 plus 6 plus 3. 6 plus 3 is 9. Bring down my 4, 49, right? So my equation is going to be 76 minus 49 equal 27. That would be one of my answers. So it's going to say up here, 27 plus what equals 49, or equals 76. So now I have 27 plus question mark equals 76. How do we find a missing addend? Well, remember what I told you. When we have a missing addend, we do the opposite of this sign. So we're going to subtract 76 minus 27. We can't take 6 away, so we have to borrow a 10. 16 minus 7 is 9. 6 minus 2 is 49. So we know that this is our problem. 76 minus 49 equal 27. What is this? Would this fit in here if we put 49 in there from over here? Yeah, that would be actually part of the fact family. So we would circle this one in. Yes. Now, we have 27 plus 49 equals 76. 76 equal question mark plus 27. Well, I'm looking at that and I'm thinking in my head, oh my goodness, we have a subtraction one and we have this one. This is part of a fact family. And this is part of the same fact family because all they did was switch the addends, switch the numbers again, right? So this would be 49 plus 27. Could we have used that one? We certainly could have. So we would circle in the yes for that one. Now 76 plus 27. Let's come down here and add that up. What are we going to get? 7 plus 6 is 13. Bring down my 3, carry my 1. 7 plus 1 is 8, plus 2 is 10. 103. Ooh. Does this work here? Is this part of anything? No, not at all. We'd have to hit a no. So 76 minus 27. Come over here and we have to subtract it out. Again, we're going to have to borrow a 10. 10 plus 6 is 16. The 7 becomes a 6. 16 minus 7 is what, everybody? 9. 6 minus 2 is 4. Could this be part of the fact family as well? It certainly could. Here's 1. 76 minus 49 is 27. That's part of a fact family. Maybe I'll put a check there. That works. That was our original problem that we found. And then the opposite of it would be 76 minus 27 equals 49. That works. And what are our addition parts of a fact family here? So the only no is this one here. The rest are yes. Okay. Okay, so we're going to do problem 3. And it says, Tim takes $75 to the store to buy some clothes. When he leaves the store, he has $19. How much does Tim spend at the store? So I know he is going, when he leaves the store and he's buying clothes, to me this is a subtraction problem because he's losing money. He's buying something, so he's not going to come out with the same amount of money. So I know I'm going to subtract. And again, I like open number lines. So what do I know? I know he starts with $75 and he ends up with 19. So we're going to subtract. 75 to 70 is 5. And we're going to go back to 60, which is going to be 10 halves. 60 to 50, 10 more halves. 50 to 40, 10 more halves. 40 to 30, 10 more halves. 30 to 20, 10 more halves. And then 20 to 19, 1 half. Okay, so I have a lot of 10s, so I can count by 10s. 10, 20, 30, 40, 50. So here we go. We have 50. I'm going to take my 3 circled numbers. 1, I'm going to take my highest number, 50, plus 1, plus 5. 0 plus 1 is 1. 1 plus 5 is 6. Bring down my 5, 56. So I have to make an equation, a subtraction equation. I know $75 was what I started with. I'm missing a part here, and I end up with $19. So how much did I spend? I spent $56. $56 equal 19. So that's how you would solve 3. Okay, Munchkins, I want you to do number 4, and number 5 by yourself. Thanks. Have a good day.